Hi folks, Modelling Mark here again. In this video I'm going to machine down the column and show you how I'm going to machine the cotter pins. The column is 7/8 inch silver steel. Annoyingly it's just too wide to go down the throat of the chuck, so that's going to give me a little bit extra to think about to machine that. The cotter pins are made out of 1/2 inch brass. I believe steel would actually give a better grip. Steel on steel has a greater coefficient of friction than steel on brass, but there was some brass supplied in the kit, so I'll use that. Moving on to the column, I've got to turn the end down to 3/4 inch diameter. Now here's an interesting conundrum. It's too wide to go down the throat of the chuck. Now I thought the only way I can do it is to use the fixed steady to steady the end, then I'll be able to turn and face the far end. However, to clock it I need the saddle on the inside of the steady rest, and to turn it I need the saddle on the outside of the steady rest. So the only solution I came up with was to put the bar in the steady rest, clock it like this, then drill a centre in the end. Then I can use the centre to support the bar when I've moved the saddle to the outside of the steady rest. And then I should be able to turn and face the end, and of course face off the other end. So let's see how that works. I don't know how well you can see the clock, but in the horizontal it's within a thou. And in the vertical it's within about 1/2 thou. That's good enough. Plenty of oil on the fixed steady, and then I'll drill the centre. Now I removed the fixed steady, wound the carriage out, then I put the fixed steady back with the bar supported by the centre in the tailstock. That now seems to be still running true, so I'm quite happy with that. Now it's a straightforward process to turn the end down to 3/4 inch diameter. And just one final measure to confirm that we're down to size. Yeah, that looks about right. Now I can take the tailstock and the centre out of the way. Now I can try the base in place. Yeah, that slides on very nicely. Yeah, good sliding fit. Just the faintest hint of play, but no perceptible wobble. Yeah, I'm pleased with that. Just the fit I was aiming for. And the final machining operation is to clean up the ends. Of course, the ends haven't been faced off yet. I just faced the end to clean up the saw marks and give me a nice machine finish. I didn't worry too much about taking out the centre pip, so I think that looks okay on the tool. Both ends were done the same way. I only showed one because there's no point in showing both, it's just repeating myself. Right, and here's the completed column. It came out quite well. You can see I've faced off the top and the bottom but left the centre pips in. I think they look fine, and I didn't want to shorten the bar too much. Now it's on to the cotter pins. I'll start by putting a piece of face-off brass bar in the collet block in the mill. Then I've edge found with the DRO to find the centre of the bar and the end of it. The pointer shows where I've zeroed out the DRO. Now to find the centre of the main column, I need to offset the y-axis by 17/32 or 0.531, and the x-axis needs to be offset by 0.6875. Then the fly cutter will cut an arc which exactly matches the radius and position of the main column. Now I can zero that position. I'll do that in the incremental so I don't lose the absolute value of the end of the bar. Now I've set a fly cutter carefully so it's cutting a 3/4 inch diameter. Now I locked the x-axis and I wound the y-axis out so the fly cutter is beyond the edge of the bar. Now I'm just taking progressive cuts, about 5 thou at a time, winding the y-axis back in, and I'll carry on until the DRO hits 00, and that should put the fly cutter on the centre of the main column and I'll get the perfect arc. And certainly the arc cut out of the brass bar seems to fit nicely on the 3/4 inch plug that I've been using. Now I need to cut the brass bar in half to make the 2 cotter pins. This is done with a 2mm slitting saw. I touched it off on the top of the brass bar, then dropped it down by 0.6875 plus 1mm to allow for the thickness of the slitting saw. And now it's just a case of chopping it in half. You can see I'm running the slitting saw at a very low speed, plenty of oil and a full depth of cut. The slitting saw does seem to be happy taking a full depth of cut, but just a very slow feed and a slow speed. Now it's a simple parting off operation to cut the lower cotter pin from the stock. Both cotter pins have been left deliberately over length at the moment. They'll be trimmed down to their final length later on in the build once the ball handles have been made. Now the ball handles are going to have a shaft with an M6 thread on. So one of the cotter pins needs an M6 thread in it, and the other one needs an M6 clearance hole. I'll show the drilling of the one with the M6 clearance hole. The one with the threading is almost the same, but I won't show the threading because trying to video a threading operation is a pain in the neck. And there's their two finished cotter pins. Still slightly over length, but nicely deburred. But do they work? That's moderate finger pressure. I'm not lifting the base, that's the pins gripping the weight of the base. As you can see, if I take the pressure off, it drops off instantly. So yeah, they do work. They seem to work remarkably well. I'm not applying a great amount of pressure there, but it is holding the base very firmly. The next video should be the machining of the arms. If you enjoyed the video, please click the like and subscribe. I really appreciate it. Thanks again. See you next time.